Just a little bit about our school. I know probably 1/3 of the audience is from the school, but perhaps for those of you who are not from the school, it's worth probably for us to introduce who we are. In our school, we have several programs in architecture, landscape architecture, planning, urban design, and the new one, property, which will start next year. So we offer a 3-year Bachelor of Architecture Design, which is the foundation program for various master's programs. So in architecture, landscape architecture, planning, urban design, and property. Also double degree in some of these, so architecture and landscape architecture. You can do it for 3 years. Landscape architecture, planning, urban design, as well as with property. We also offer a range of a PhD program with a range of areas, but I guess the 3 main area of focus of research are sustainable built environment, architectural history, theory and culture, and design research. And within these areas, then we have Center for Asian and Middle Eastern Architecture, and a new one, which is the China-Australia Sustainable Research Unit. My research falls into these 2, but it doesn't mean we don't talk to each other. We're actually quite a small school, and we would like, and we do collaborate in between the areas as much as we can. So as Paul mentioned, and as the title of the talk already says, the talk tonight is about an area that I think, one of the areas that is close to my heart is about green buildings. The focus is on how green is green building. So before I started this, or when I was preparing this presentation, probably as many of you would do, or even your children, if they want to find out something, what do? You Google things. So out of interest, I just Googled the term green buildings. And within 0.32 seconds, there are 69,300,000 entries about green buildings. And I thought, well, do you know how many minutes are there in 1 year? There's 8,760 hours. So there's 525,600 minutes in a year. So if I sat down and went through every single site, just spend 1 minute, it would take me 131 years and 9 months to do it. Well, I think I have other things to do, so I didn't do it. But it probably shows, well, maybe people do love green buildings. That's why they put a lot of sites about it, but maybe people don't like it, so that's why they also put a lot of entries in there. But I didn't go through that. But the interesting thing is, once I click images, of course, everything turned green. And you see that, people say, okay, if you put plants on your facade, that is called green building. Anything green is green building. Well, is that so? So is that really what green building means? I believe that most of you probably are aware in what sort of area is this, the term is referring to. So I guess the idea of building something that is responsive to the environment and creating spaces that are suitable for occupants without leaving much negative impact on the environment is not really anything new. Historical evidence show that for a long time, people knew, I should say, what they're doing. They designed, developed, built spaces, whether it's also buildings, little towns, that they were responsive to the local environment as well as cultures. This particular example is an image from northern Scotland, cold climate, and people did build buildings to respond to that environment using local materials, thatch roof, pretty thick thatch roof, which perform as insulation as well. Very steep roof, slope to let the snow flow down very easily, and so on. However, as we all know also, one of the reasons that societies around the world started to ignore the context or the environment was the realization that we, people, can control our environment. Technologies have helped us condition our surrounding environment to suit our needs. So same environment, same climate, and probably still similar approach, but obviously this is a new way of designing. So still steep roof, but as you can see, with the invention of glass, we now can have buildings that can look out at any time we want, but still protecting us from the elements. But I guess the biggest invention that changed the way we design is the environmental control system, air conditioning. Because with that, we basically can build anything, anywhere, and still make people feel happy inside the building. I guess the other two inventions that we've done, what we've developed or we founded, are the structural system itself. We can build as many stories as we like. We can manage the structural system on it, but also elevators. Lifts allow us to go high as many as we want. So, but the biggest part of that is really this air conditioning system that allow us to build buildings such as this in Sydney or in the tropics. They all look the same. Theoretically or logically, you probably think they shouldn't be looking the same, but they do, well, because we can control the environment. So I don't mean to repeat this statement, but perhaps it's worth just reminding us, such developments are really not without impact. We know that the built environment, particularly buildings, contribute to 30% of total greenhouse gas emissions and use 40% of total energy consumption globally, mainly due to these environmental systems and also the construction itself. So building, construction, as well as the environmental impact from the building and the operation has impact. So when did the term green building start? So despite the fact that we, society, understood the context, the environment, the constraint it had for a long time and responded well to that, then we started to change, and that change had impact on our environment. But back in the 1970s, and those of you I'm sure quite well aware of this, when the oil crisis happened in a lot of developed countries due to the oil embargo from the Organization of Petroleum Exporting Countries, OPEC, when they tried to say, no, we don't want developed countries to tell us how much energy costs or fuel costs should be, and then they increased the price. And obviously people and countries that depended on oil then struggled because oil prices all of a sudden went up. And at around that time, then there came a realization that if we don't try to minimize the need for oil, we could suffer. And the green building movement started about the same time when they started to think, or a number of countries realized that unless we change the way we build, there's a lot of impact on the environment of what we do, and then we keep needing more and more oil. So the idea of green building is really a shift from standard building practices, which is typically guided by short-term economic consideration, to best practices, emphasizing quality construction, reducing energy, improving energy efficiency, improving indoor air quality, conserve water and other resources through thoughtful planning and design for human productivity and health. So it's not about building with plans. I think it's more holistic than that. It's looking at the life cycle of the building from construction to use to demolition to reuse by considering environmental and social impacts. However, I think I personally would say that, well, it should not be just environmental and social impacts. I think economic considerations should also be put into the equation. And that is probably one of the debates also, is that really green if we do it at all costs? My answer is, should not be. But to reiterate, basically, green building is a label applied to a building that is designed, constructed, and operated in a way that it will use resource efficiently and reduce negative impact on natural environment while providing a healthy condition for the occupants. So the issue of occupants are as important as the impact on the environment. So it's not just about reducing the impact on the environment. So how can we achieve that? So because the notion of green building encompasses a lot of issues, and these are just some of them, I guess the first thing, if we are interested to keep or to commit to green buildings, we need to set clear targets. What are the targets? And it could be about the indoor environment, so it's about the people, once again, comfort, light, reducing noise, improving indoor air quality, minimizing energy, water waste, reducing materials that are used. So it's not just about operation, but once again, at what cost to the materials that we use and the cost to the environment. Improving the ecology, and in terms of people, again, productivity, health, and so on. Now, obviously, there's no one set target. It depends on the context, depends on your client. Some clients would set up this target, what I call it informal, but the targets can also be formalized, whether it's through building code or other means. So let's pick up just two things. Now, there are a lot because there's a lot of aspects, including in green building concept, and we only have less than an hour to talk about this. I'm just picking two areas, comfort and energy, as an example. So in this case, there are a formal target, which is a mandatory target that, for example, a government would set up. In Australia, for the residential building sector, for example, you have a building code that you have to meet, the energy efficiency provisions that you have to meet, as well as in the commercial building sector. So one could be mandatory, but there's also a voluntary, so even though it's a formalized target, but not every building has to meet that. So in the mandatory one, an example of that is what we call NETHRS. I'm sure some of you would know NETHRS, the National Home Energy Rating Scheme. So new residential buildings need to comply or to meet the NETHRS requirement. And you hear a lot about the notion of star rating. I'm sure you heard that. So house nowadays, you can't build a house if it doesn't achieve 6 stars. Okay? So that is set up by the building code through this mechanism, which is the National Home Energy Rating Scheme. For commercial buildings, there is a voluntary scheme called Green Star, which is set up by the Green Building Council. And you heard this, something called 4-star, 5-star, 6-star. 6-star is the world leader, and Adelaide University has the first 6-star Green Star rated education building, which is the Inkandi Wadley building, the engineering building. But that is a voluntary scheme. Not every commercial building has to go through Green Star, basically. But Green Star has been used also to make people aware of the environmental impact of commercial buildings, but also can have positive impact in terms of marketing value, because a building that is Green Star rated is often perceived as has higher value. So the question is, how do we achieve these many targets? What do we do? But the other question that later I'm going to talk about is, how do we know that these targets have been achieved? Looking at the actual definition of Green Star. So in terms of how do we achieve it, there are many ways of doing it, and I'm sure people in the audience, some of you have done so-called green building, would agree with me. I suppose the first step to achieve all these many targets is working collaboratively from day one. So it's not an architect come up with the design, once it's completed, give it to the engineers, and so on. But even from day one, everybody talk together and then set the targets and developing the design with the other parts of the design team. And to do that, you can then use your previous experience and using design guidelines and so on to achieve the target. Also, of course, meeting the code. So you get all sorts of supporting documents that you have to go through to achieve the target. At the end of the spectrum is to ensure that the target has been achieved, then you can do what we call the performance assessment, which I'll go in a minute later. But the other thing also that is probably a bit more powerful than just simply using rule of thumb and design guideline is something called simulation. So a lot of these, while we're designing, you don't really know what the answer is unless you simulate it. So by simulation, I mean really using a program, simulation program, to predict what would be the comfort level in the building, what would be the light level in that building, what would be the noise level, the CO2 level, the energy consumption, water waste, and so on. So that could be predicted by simulation. And that is very important to understand because the actual formal target that is set up through building code, for example, in the residential building sector through NATRS, that is also simulation. So it's not a real performance, it's predicted performance done using simulation. Okay, so if you hear a 6-star building or 10-star building even, that is actually predicted simulation. It's not real. So once again, the question is, how do we know that is the real thing that will be achieved? So, but before we talk about that, let me just talk a little bit about simulation. This is really simplification, but just to get a feeling. So for those of you who are not familiar with this, suppose you have a building design. Basically, what do we do in simulation? You need to tell the simulation program where the building is, because then that would bring the weather information about that, because how building performs depends on the weather condition. The surroundings, so you have to know whether it's surrounded by other buildings, by trees, is there any road around it, water bodies, and so on. You need to say what the building will be used for, how many people probably, either lighting, equipment, anything that is affecting the internal condition, materials around the building and inside the building, so the building envelope and so on. And if the building uses heating and cooling system, then you also need to say what is the system that is being used and how are they going to use it and so on. So all of these then will be taken into account in the prediction. Then you then can predict, based on all of these parameters, what is the condition in the building, if they need to be air conditioned, how much energy will be used for the heating, cooling, how much water will be used, and so on and so forth. Just as a description, a bit of example of a simulation. This is actually a student project. I think the owner of this work is actually in the room, so thank you for letting me use this project. As an example, this is a group of honor students from architecture engineering just recently looking at using Gabion wall for a house. So is it possible to use Gabion wall for a house? And so using simulation, they can predict the temperature in the house, lighting level, all sorts of other things. So that's an example of illustration, what can come up of the simulation. And you can compare different kind of materials. The rating that I mentioned before, if you look at the actual output, it looks something like this. So you enter all these building properties and how to use it, and it comes up with the predicted heating and cooling load, and it gives you the star rating. So the star rating is based on the band of 1 to 10. It has certain values, then it gives you the star rating. Also, you can predict what is the temperature in the building if it's not air conditioned. In the commercial building, you can also simulate a similar thing. And once again, this is a student project from last year where they simulate an office building using a program called Design Builder. And what you can predict, for example, is monthly electricity, monthly gas use. And this then will be used to predict the Green Star rating performance. Now, Green Star, just quickly, it's not just about energy. There are other aspects that are assessed. So management, indoor air quality, transport, water, materials. But energy does play a big role. So the simulation then would be fed to the Green Star rating, and with all of the other assessments, then a building design will be awarded some star rating, whether it's 5 or 6, 4, and so on. So that's in a nutshell. So once again, all of those star ratings that we heard about, that is not real performance, it's predicted performance. So we are interested in looking at, are predicted green the same as actual green? So about 2 years ago, one of our PhD students conducted this research. Now, the study about confirming the greenness of claimed to be green buildings is not new. There have been studies around the world, and the outcome is not conclusive. So sometimes they find green buildings perform better than non-green buildings, sometimes they're not. This study is the first in Adelaide, as far as we know, to look at the performance of Green Star rated commercial office buildings and conventional, which are buildings that are not Green Star rated. But as you can see that because there are a lot of factors in Green Star assessment, there's no time to look at every single one. The study focused on the energy and water consumption, as well as the indoor air aspects, and as well as the occupant. Because once again, if you remember the definition of Green Star, it's not just about, green building is not just about the environmental aspect, but social aspect is important. So she looked at also the occupant satisfaction. The work was done through monitoring. So there's monitoring of the indoor condition, temperature, humidity, lighting, actually also noise level. Looking at 4 conventional buildings, 4 Green Star rated building, and 1 green intention. Now you probably say, gee, that's not many. It is a big challenge to find buildings that wanted to participate. Letters were sent to many buildings, and not many wanted to, I suppose, not many wanted to be known how the buildings actually perform, possibly. But also they don't want the occupants to be disturbed by the study. We were helped quite significantly by the Departments of Premiers and Cabinet, which was very helpful. And we had 9 officers participated from the government's office, and they all, luckily, were in conventional buildings as well as the Green Star rated buildings, so we had a comparison of that. There is one building called Green Intention. Now this one was a building that was perceived or looked like they're kind of green, but they're not rated officially. But from publication about this building, it seemed to be green, quote unquote. Once we gathered the buildings that were willing to participate, then she conducted the occupant survey. There were more than 600 people participated, so it's quite a large number of people participated. And basically, the questions were about including job satisfaction, workplace, perceived satisfaction of comfort, lighting, acoustics, health, productivity, building design, as well as building use education. Okay, now let's look at the result. The first is the energy consumption. So this is the total energy consumption. So the 2 lines, the light colored one is what we call the base building energy, so as if just the skeleton of the building, not including the tenancy, people renting the office spaces. So the blue one is the energy that are used by the tenants, and these are the average out of those 4. So that is the total energy consumption, I should say the monthly energy consumption from February to the following year in May. That's a conventional building, and that's the Green Star rated building. So it's quite pleasing, I suppose, to see that the Green Star buildings did or do use approximately half of the conventional building. The light color plot is looking at the temperature. So as you can see, when the temperature is quite low, which is the winter, that's when apparently the higher energy. We'll look at it in a different way of looking at this data. So apologize to those of you who don't really like Excel, but we like Excel. So basically, these are the 4 buildings and the average energy consumption versus temperature. So this is the temperature, monthly temperature, and this is the energy consumption. What this graph says is the lower the temperature, the higher the energy consumption. which it was a bit counterintuitive for us in the beginning because we always thought energy use would be the highest in the summer. But in Adelaide, because we have winter and we also use a lot in our buildings, that the gas use in winter actually, when we total that, it actually makes the energy consumption higher compared to summer. Once again, it was counterintuitive than what we thought. And it was the same with the green building, but once again, as you can see, it's half of what we found in the Green Star rated building. But similarly, energy consumption, total energy consumption is actually higher in winter than in summer. Interestingly, the green intention building used not too bad. I mean, it's only slightly higher than the Green Star rated building, despite the fact it's not officially rated with Green Star. And then we look at water, same thing. This is the water consumption in the conventional building, and the Green Star rated building also use less water, showing that the water is more efficient also for the cooling season. So often water is used for the cooling system, but in Green Star building they use much less. Interestingly, the green intention building has less water per meter square, and in this building water is not much used for the cooling system. Okay, so those two aspects, we could confirm that the Green Star rated building actually performed better than the conventional buildings. Now look at the people's perception. There are many aspects of this, so these are just some of them. The report actually goes pages after pages, and I just picked some of these. So in terms of building design, so the scale here shows unsatisfactory is the lower scale, and then the 7 is actually the highest or the most satisfactory, or the good and the poor. The green indicated the green building, the blue is conventional building, and the red is the green intention building. So in terms of building design, overall, the response about that the building is quite nice and we like the building, we have better response for the green building. So occupants in the green buildings feel that the building is more satisfactory in terms of how it looks, how they use it, and so on. It has better image and also provides better safety. But once you look at down here, there's some of them sort of the conventional building is similar to the Green Star building. Interestingly, in terms of cleaning, most of the occupants in the Green Star buildings don't think that the building is as clean as they wanted. We don't know why, but the conventional building seems to perform better in terms of the cleanliness of the building. And then we look at other things, for example, the winter conditions. In this case, we found that the satisfactory is kind of similar. So if we look at from the 4, which is the middle point, and above, so the conventional building performed better in that score, as well as at 7, but between the 5 and 6, the Green Star performs better. So if you total it, it performs relatively similar. Summer, however, the Green Star rated building performed better. So people perceive the summer condition in the Green Star building is better than in the conventional building. Noise, however, is a big issue, and this is not unique to the findings we find in the Adelaide study. Studies around the world show that a lot of office buildings that are similar to Green Star. So in America, it's called LEED. In the UK, it's called BREEAM, similar scheme. Noise is often an issue in Green Star rated commercial buildings, and that is because most of these buildings, because they try to minimize the energy for lighting, what happens? There's big windows and less partitions. And when you have less partition in office buildings, tend to be quite noisy. So in the conventional building, there's a lot more satisfactory in terms of noise control, and the Green Star rated building is basically have the most unsatisfactory perception by the people. So it's much noisier. So for example, just as an illustration, this is the conventional building. This is one of the Green Star buildings. So it looks like the Green Star rated building has a lot more open spaces Despite the fact both have partitions, but the older buildings tend to have more sort of nook and crannies where people can hide and have a bit more privacy compared to the Green Star rated building. Once again, a lot of glass make an impact. And that is also reflected with the second result that is also not just typical to Adelaide, but around the world, is the lighting issue. As you can see, so this is the lighting satisfaction overall. So the blue line here is, once again, is the conventional building has more satisfactory in terms of lighting. And this is simply due to the fact that this is natural light. This one now is about too much and too little. And in Green Star building, basically there's too much light compared to the conventional building, as well as glare. And due to that, it has a lot more glare. And of course, the reverse of that, in conventional building, you got a lot more artificial lighting, hence higher energy, but people are happier because there's less glare. So that's the sort of, which one do you go first? Is it energy, is it people, and so on. How do you strike the balance on that? So in conclusion, in these studies, that the Green Star rated buildings use less energy and water than conventional buildings, but the response in terms of occupant satisfaction is actually, if you take it overall, the Green Star building is not outperforming the conventional building. I kind of skipped the green intention, but as you can see, the green intention buildings perform basically the best in terms of the occupants' satisfaction, which is quite interesting. In all areas, mostly they are more satisfactory than the other two, despite the fact, once again, it wasn't rated officially through the Green Star. So then we look at also another example of this, looking at the actual performance is we look at the residential building. So this one example project, part of a project with the University of South Australia in developing a framework of adaptation of Australian households to heat waves. It's supported by the National Climate Change Adaptation Research Facility. So the overall projects, we monitored 60 dwellings, 20 in Adelaide, 20 in Sydney, and 20 in Brisbane. In this particular case or example I'm discussing here, we look at the performance of the smaller dwellings that we monitored. And it's a housing complex for low to middle income people. It's quite simple design with one living kitchen area as one area, 2 bedrooms facing the north side. This is the living area. And it does implement a lot of good design principles. And it has been rated with the NATHERS rating tool. And overall, the whole development has 7.5 star, which is the minimum that development required. This particular one had 7.4, but it's kind of pretty close to 7.5. So the idea of this design is relies on, if it could, natural ventilation. It's got what we call stack ventilation. So there is a chimney up here. I hope you can see that. Oh, I can't really see it, but there's a chimney up here where the idea is if you open this opening, it would draw the hot air up and then induce ventilation. It does have air conditioning, but it's only used in the living room or installed in the living room. So once again, the building has 7.5 stars. So what did we do? Apart from monitoring the condition inside the building, we also asked people to respond to what we call thermal comfort survey. The difference between this and the previous study, in the previous study, we did not ask people to say what they feel every single time. It was a sort of an overall comfort perception for the whole season, whereas this one is as often as we would like them to respond. And the survey asks for which room they're in, what they feel at the time, so hot, warm, cool, cold, and so on, whether they want change, is there any window open, air conditioning running, and so on, and what type of clothing they have. So we do this either on paper or they can also do it on their mobile phone. So what happened is we send out automatic reminder and they would receive message and they just answer the survey. What we find in the monitoring is that overall, the building is not too bad. So this is, sorry, without air conditioning. So this was in the summer of 2012. So overall, the building is, you know, you probably say, oh, it's quite all right, but there are times when the building is quite warm. Now, you might wonder, why do they let the temperature sort of goes up to even 35 degrees, despite the fact there's air conditioning? And before I answer that, let me show you the result of what they answer. So this is what we call the thermal sensation. Sorry, it's a bit too technical, but basically this is the response. Anything above 0, basically warm to hot. This is cool to cold. So overall, they tend to answer the building is quite warm. But they don't really do much, or they don't really run the air conditioning. When we ask why they don't do it, well, they said, first of all, we usually turn on the fan and open, close windows, curtain, and so on, and turning on air conditioning was the last resort. So we asked them why. They said, well, we were told the building is green building, so it should be all right. It's quite interesting. So even though they feel it's warm, I think they feel guilty if they turn on the air conditioning. But number two, they said, a lot of them said, we can't afford it because, you know, I only earn $20,000 a year. I can't turn on the air conditioning. Some actually decided, when they knew it was heat wave coming, they decided to go to their relatives so they don't have to suffer in their own house. Now, this is despite the fact that the house was supposed to be 7.5 stars. As you remember, the star rating is once again based on prediction of heating and cooling. So if they do turn on the cooling, the idea is, well, that 7.5 stars equate small amount of energy. So if they turn on the air conditioning, probably it would be okay. The problem is the air conditioning was only in the living room, and upon closer look, it was the diffuser is only there facing that way. So the bedrooms are always quite warm. So at night, if they want to be a bit cool, they have to move to the living room. And some people didn't want to do that. So then what do we looked at? Then what we did was, okay, what would have happened if the design was rather different? So what we do is, we know there's the rating results. We just want to confirm that the rating is the right rating. So we look at what the prediction is and we compare it with our simulation. And they match, which means the prediction is correct. So it's not saying that prediction is not correct. It is actually correct, and this is the comparison between the simulation and the actual measurement. But what had happened, now this is the actual building. So the building is supposed to have natural ventilation. So even though if they feel warm, it should still work if they can open the window. That's the only opening they have. Okay, so it's quite small, and this unfortunately did not get captured in this rating tool, because the rating tool assumed the building would be air conditioned and the window would be shut. And that's how the rating is based on, is that assumption. In reality, if people want to not use energy at all and try to open the window, they can't. So when we did simulation, we found that if the window, this simple design is done differently, let's say the window is casement and you can open it totally, the number of hours that people would feel warm actually can be significantly reduced, even up to 40%. So once again, what we find is, despite the fact that the building design achieved high star rating, supposed to be representation of the greenness of the building in terms of energy, individual spaces actually are less than ideal. And rating the entire design can potentially mask the performance of certain spaces at crucial times. And once again, we found that unless you actually look at the performance of the building, you know, how green is green, probably we don't know. But unless we assess the actual performance, then that's when we can improve the performance of the building. Now, all of this, obviously, I haven't talked much about the building materials, the construction, which is another aspect of green building. Currently in the school, our head of school, George Delante, is finishing project in looking at waste, construction waste, which is another big area. So often, once again, we look at the greenness of the building from one aspect and forget one thing, in this case, the occupants, but also the making of the building itself is often not included. So my perception is not all buildings that are considered green are really all green. It depends on what measures you use. But to continue to have true green buildings, I think we need to have continuous feedback. And that's when post-occupancy is very important. Otherwise, we don't know exactly what happened. The problem is not every buildings would like to be evaluated. Not every building owner would like to know, or maybe the designer don't want to be found out if their design was not as good as it was claimed. It is a big challenge. However, I think our role as a researcher is to be critical about what's out there, and through that, hopefully we can contribute back to the design community, to the building community, that all these findings hopefully can be addressed for new building design. That's all from me, so thank you for coming.